Okay, now here are some expressions, and what I need to do with them is I need to rationalize the denominator. Okay, so that would mean that the denominator should not have a surd like these do. Okay, so we don't want a surd there. Now we know that if I was to multiply root 7 by root 7, that just gives me 7. Okay, but I need to write an equivalent fraction to this, so I would need to times the top and bottom by the same thing, or I can think of it like I'm timesing by root 7 over root 7. Okay, now remember, root 7 over root 7 is just 1, so timesing by 1 doesn't change my fraction. I still have an equivalent fraction to what I started with. So this then becomes 3 root 7 over 7. Okay, and now I don't have a surd in the denominator anymore. I've just got 7. Now here, the second one, I have 5 divided by 2 root 3. For this one, if I just multiply the top and bottom by root 3, that gives me a whole number at the bottom. So times by root 3 there, times by root 3 there. And this will give me 5 root 3 over, now 2 times root 3 times root 3. So root 3 times root 3 is just 3. So 2 times 3. Okay, 2 times 3 is 6, but I'll just write 2 times 3 first. And then we've got 5 root 3 over 6. Okay, and I can check if this fraction simplifies and this one doesn't. Now in this third example, I've got root 6 over 2 root 2. Now root 6 doesn't simplify. I can't think of a factor of 6 that is a square number. Okay, so I can't simplify this. I can't simplify this now. But let me rationalize the denominator first by multiplying top and bottom by root 2 and see what happens. So times by root 2 and times this by root 2. What I have is root 6 root 2 over, now this time root 2 times root 2 is just 2, and 2 times 2 will give me 4, so I'll just write the 4 here. Now remember, root 6 times root 2 is just root 12. Okay, I can just multiply them and just take the square root of that. Now root 12 simplifies, okay, but I'm just going to write root 12 first. So root 12 over 4. Root 12 simplifies because 4 times 3 gives me 12, okay? So this is going to be root 4 root 3 over 4. Now root 4 is 2, so 2 root 3 over 4. And this fraction simplifies, okay? I can divide the top by 2, and that will be giving me root 3. And I can divide 4 by 2, and that will give me 2, okay? So divide top and bottom by 2, I'm going to get root 3 over 4. Okay, so we need to also be able to rationalize denominators like this. In this case, okay, the technique is to multiply top and bottom by this same thing but a negative here, okay, because what that does is it cancels out the middle term. So if I times by 2 take away root 3 and times the top by 2 take away root 3, okay, remember this is going to be 2 times 2 and 2 times negative root 3. Then I'm going to have root 3 times 2, which is a positive 2 root 3. And remember I had 2 times negative root 3, which is a negative 2 root 3. And these two terms cancel out. And then I have root 3 times negative root 3, which will just give me take away 3, or negative 3. Okay, so that's the technique to rationalize the denominator when you have such an expression like this. Okay, and I'll use the same kind of technique here. So here I'm going to have 5 times 2 take away root 3. Okay, and the bottom, I'm just going to multiply them out. So remember that all of this was multiplied by this bracket. So 2 times 2 is 4. 2 times this negative root 3 is take away 2 root 3. Then I have root 3 times 2 is 2 root 3, so adding 2 root 3. And the last bit I have is positive root 3 times negative root 3. Okay, so the positive and the negative will give me a negative. And the root 3 times root 3 is going to give me 3. Okay, so this is what I have. Now I'm going to try and simplify it now, and I'm going to multiply at the top. So the top's going to be 5 times 2, which is 10. 5 times the negative root 3, which is negative 5 root 3. Here, the 4 take away 3 will give me a 1. And this negative 2 root 3 and adding 2 root 3 here, they're just going to cancel each other out. Okay, so I'm going to be left with 1 at the bottom, and at the top I'm going to have 10 take away 5 root 3 over 1. Now dividing anything by 1 is just that. Okay, so 10 take away 5 root 3 would be my answer here. Now in this one, again I'm going to use the same technique here. I'm going to multiply this bottom by 2 plus 3 root 2, so that my middle terms cancel out when I multiply it. Okay, so times this by 2 plus 3 root 2, and show that you're going to have to times all of this by, we're timesing all of this by this bit here, and the same for the top. Okay, so times by 2 plus 3 root 2. So I'm timesing the top and bottom of the fraction by the same thing, so I'll get what is an equivalent fraction to this. And again, I'm timesing all of this by that, so that my whole numerator is being multiplied by this thing here. So I need to put it in brackets. So this time I'm going to write it out as 3 times this and root 2 times this. And at the bottom I'm going to write 2 times this bracket and negative 3 root 2 times this bracket. So this is going to be 3 times 2 plus 3 root 2, and then I say plus this time, so I did 3 times all of this, and I have to do root 2 times all of that. So plus root 2 times 2 plus 3 root 2, and that's going to be over. So this time 2 times all of that, and negative 3 root 2 times all of that. So that's 2 bracket 2 plus 3 root 2, and take away 3 root 2 times 2 plus 3 root 2. Okay, so now I'm just going to multiply these out, okay, and see what I get at the top, see what I get at the bottom. So I'll have at the top, I'm going to have 6 plus, so now 3 times 3 root 2, that's going to be 3 lots of 3 root 2, that's 9 root 2. 9 root 2 plus 2 root 2, and then this one, root 2 times this bit here, 3 root 2 times root 2 is just 3 times 2, which is 6, plus 6. It's going to be all over. 2 times 2 is 4, 2 times that is 6 root 2, so we've got 4 plus 6 root 2, and here I've got negative 3 root 2 times 2, that's going to give me a negative 6 root 2, negative 6 root 2, and negative 3 root 2 times positive 3 root 2, so 3 times 3 will give me 9, and root 2 times root 2 will give me 2, so it's going to be 9 times 2, which is 18. Okay, so it's going to be take away 18. So again, you can see that these middle terms cancel because of what we chose to multiply this by. Okay, so these middle two terms will cancel, and I'll have 4 take away 18 at the bottom. At the top, I've got 6 and 6, which add together to make 12. 9 root 2 add 2 root 2 is 11 root 2. Okay, so we will have 12 plus 11 root 2 over, so remember we said that these ones will cancel, and 4 take away 18 is going to give us negative 14. Okay, so I can write it like this, or I can actually say this is going to be negative 12 plus 11 root 2 over 14. Okay, now I can't see any common factors of 12, 11 and 14, so this won't simplify any further. Now here are some questions for you to practice. Okay, so rationalize the denominator for these expressions here.